Hello guys, today I'm gonna show you how to know if your lid is going to burn or not if you replace it in your circuit. Each lid has a number of watts, so how can you determine that? So for me, I took the 2.2 volts lid, that's the maximum voltage as you see here. Let me give you a closer look. I don't know if you can see, and that's the max current. As we know, power equal to voltage multiplied by current. So for us, the voltage is 2.2 maximum voltage multiplied by maximum current. So it is multiplied by 0.02. So it is equal to 0.044. So I will write it somewhere here. Let me talk a little bit about breadboard. So here we have two rows. Each row has holes. Those holes are connected like that, like row, but plus and minus rows are separated. So that one is not connected with that one. I mean, from here to here is not connected with that one. So let me test it. I will set my multimeter to 20 volt. I will test first the first one. So from here to here you will get 3.3 volts. Here you will not get anything, so there is no power here until I plugged wire 3.20 to 29. Okay, so I reversed those pins. If I reverse them again, I will get a positive value. That's why I got a negative value. So now we will test a normal lid to know the maximum amperes that get out from the power supply. First I will set my multimeter to ampere. 200 milliampere will be good, so I will plug my minus to minus. It is around let's say 20 milliampere. If I multiply 3.3 multiplied by 0.02, I will get 6.66. As we see, watts in the power supply are higher than our lid. So if we try to plug that lid, so I took the lid from here. If we try to plug that lid with our power supply, it will be burned because the lid needs 0.044 watts and the power supply gives 0.066. So that means the power supply is higher, but we need the lid to be higher, the watts in the lid be higher. So we will add a resistor to fix that thing, but before that let me show you that one. So this is our lid. If I plug it directly, it will be burned. So if you plugged your lid like that in the same column, you will get a short circuit. So do not do that. You should plug it to two different two different columns. So that one is the plus, that one is the minus. So I'll plug the plus and you will see that the lid will be burned. You see, the lid is now burned and we've burned the lid. Congratulations. So after that, to not burn that lid, there is an equation. So to calculate the power, P power equal voltage multiplied by current. So that's the thing that we did to calculate the power of each lid, and not each lid, actually that lid and the power supply. And we found out that the power supply is much powerful than the lid, so the lid will be burned. Now we will test which resistance we need to make the lid work fine and not burn. So do 0.006 66 minus 0.006. 0.044. So that's the average that we need. We need a resistance that gives that value. So how can we find this? So P equal voltage multiplied by current. So we need a resistor. So P equal to resistor multiplied by current square. The current is 20 milliampere. The power we have is 0.022. We will divide it by current square, and it will gives us the resistance. So that's the resistance we need. It is 55 ohm. So I don't have the 55 ohm. Let me test one in front of you, and you can determine the resistance by colors. So I will not get in details, but today I will measure it with my multimeter because it is way easier to do it. So I will plug my minus here and my plus here. Our resistor has 218 ohm. So 218 multiplied by 0.2, and that's the amount of power that it will reduce. So it is way enough for our lid. So we will add that one to our lid that has 0.44, I guess. That's the value. It is 1. 0.13 is bigger than the power supply that deliver 0.066. So now our lid will work fine. That's our resistor. I show you. So as you see, it is the same value. So now I'll plug it with our lid. So this is the plus, this is the minus one. The longest one is the plus. You can plug the resistor at the plus or at the minus. It doesn't affect the circuit. So now I will check the minus from minus, the plus from plus. I'll put the plus here, the minus at the end of the resistor. There it is, as you see, working fine. In some cases there are some lids that don't need a resistor, so for that one it does work fine in 5 volts or 3.3 volts. So now I'll plug it to see. You see, it does work fine, but that one needs to be protected by the resistor. So that's it. I hope you enjoyed, and thank you.